Hello, ladies and gentlemen. My name is Boyi. We recently announced that we were preparing this channel to discuss issues in science and philosophy. And yes, the studio work is on progress, and we have decided that in science we will begin to look into the intricacies of quantum mechanics, as some people consider it an intricacy, and clear the misconceptions about quantum mechanics, because it is clear that most of people, both with scientific and non-scientific background, have a misconception about quantum mechanics as if it is one kind of magic or esoteric science. No, there is no clear cut between quantum mechanics and classical mechanics, not even a clear cut between relativistic mechanics and classical mechanics. Their problem is improved means of observation, of looking into the heart of subatomic particles, reveals some things that are not very much in defiance to the classical tenets. But as particles get smaller, probabilities will grow. This is where the misconception arises. Sometimes prominent architects of the subject of quantum mechanics are quoted out of context to tell people that quantum mechanics is a kind of something that no one can understand. I remember a professor of physics, a prominent professor as such, presenting the topic to his class, saying that he had both good news and bad news for the class. That the good news was, the bad news was that quantum mechanics was difficult to understand, and the good news is that nobody understands quantum mechanics. And that is not, I think, a proper way of introducing a new subject to a class. Another misconception about quantum mechanics was quoting one of its architects out of context. That was Richard Feynman, who said that there was a time when it was claimed that only 12 scientists in the world understood special theory of relativity, but he could assure his audience at the time that nobody understood quantum mechanics. Well, those who brought about the birth of quantum mechanics did not wake up one day and said, okay, let us contradict everything that was bequeathed to us, but that was passed down to us in classical physics, like Newtonian mechanics, like classical electrodynamics, and so on. No. Improved observation compelled them to find ways which are not actually in defiance or in violation of the principle of the classical principles. And I still assure you, there is no clear cut between quantum mechanics and classical mechanics. Especially, there is an outstanding principle known as Bohr's principle of correspondence, that at some certain sizes, at some certain wavelengths and speed, quantum mechanics approximate approximates itself to classical mechanics or classical thermodynamics. It was Planck was so much interested in classical mechanics that found blackbody radiation as somehow unexplainable, but by the rules then known in classical mechanics, hence the beginning of the journey into quantum theory. Sometimes it bothers me whether what is the big deal in quantum mechanics, whether people are find it more difficult grasping the actual concepts of physics, for which you need to employ your sharp imagination and intuition. Yes, intuition and logic. Then you also, I am also unaware of whether it is the mathematics of quantum mechanics that appears a kind of strange to people. Well, anyway, I believe that for me, at the first beginning, it was the mathematics that introduced some variables that I could not find in classical mechanics. But as time goes on, with explanation of things like the uncertainty principle and other things, operators, because quantum mechanics relies on operators representing the observables, the observable phenomena, especially subatomic. So I think we will begin by introducing the problems that defied explanation in classical physics, which made physicists at the time reluctantly invent another method which most of them were skeptical of, but ultimately led to the birth of quantum theory and its mathematical expression as quantum mechanics. Then we will come and talk about how the Schrödinger theorem was a collection of other theorems like Louis de Broglie's wave-particle duality, Heisenberg uncertainty principle, all put together. But when you solve the Schrödinger equation, you arrive at Bohr's theory of the atom, as in energy levels. If you solve for energy levels, you find exactly what Bohr expressed as energy levels. So there is no big deal in it. We will explain operators. Operators have been there in mathematics. Operators have been there in classical physics. So we will talk about them. But first, we will introduce the problems that compelled people, scientists, to begin thinking about alternative ways of explanations, and such alternative ways of explanations as such will be exploited, will be explored, and we will have a grand picture of what quantum mechanics is. I hope that I intend this presentation to be both for those with scientific and mathematical background and those with none at all. Yes, the explanation of the concepts I will try to make it uh, understandable for those without scientific background, and the mathematics will be also explained. We will try to put it in plain language so that it will benefit both people of scientific background and those popular audience. So until we come with our first episode that will examine the problems that arose in classical physics that could not be explained in that could not be explained by classical theorems, then we come up with explanations that were based on quantum mechanics and later confirmed by observations. So help us God. As we said, this channel is strictly for science and philosophy. But when we talk of cosmology as a science, things are going to get intricate. But cosmology is a science that requires all those theories: quantum mechanics, classical mechanics, relativistic mechanics, general relativity, and a host of other theories put together to try to imagine to try to explain the large scale structure of the universe, its origin, its fate, and deduce from those theories a lot of things that we can know and recognize our limits in the understanding of the universe and creation as a whole. Until then, goodbye and God bless you.